Question number 16. The area of the square is 100 centimeters square. What is the area of the shaded figure? So we know the length of the whole square is 10 centimeter and width is also 10 centimeter. So if we apply the formula, the length multiplied by width is equal to 100 centimeters square. So if we look at the shaded area carefully, the triangles or the corners which are coming out from the center, if we fit these four small triangles in the empty white areas, there will be four completed shaded squares, which will be the half of the one big square. So the full length of the big square is 10 centimeters, so half of it will be 5 centimeters. Similarly, the width of the whole square is 10 centimeters, so half of it will be 5 centimeters. So we will find out the area that is equal to 25 centimeters square. So option B is the correct option here. Question number 17. The year 2022 is a special year because the digit 2 appears 3 times. This is the third time Eva the tortoise has lived through such a year with 3 identical digits. What is the youngest Eva could be by the end of 2022? So here the first year is 2022, in which 2 is repeated 3 times. So before that, in year 2000, 0 is repeated 3 times, and before 2019, 99 is the year when 9 is repeated 3 times. So if we count the total number of years from 1999 to 2022, Eva the tortoise lived 23 years. So option D is the correct option here. Question number 18. Entry wants to complete the picture so that each row, each column and each set of 4 circles connected by line segment contains the 4 numbers 1, 2, 3 and 4. What number should he write in the circle containing the question mark? So we have to take numbers out of 1, 2, 3 and 4. If we look at our first line segment, 3 and 2 is already written. So we can write 1 or 4 here. So let's write 4 here and 1 here. Now let's move towards the next line segment. If we see in the third column, 2 and 1 are already present. So we have to choose either 3 or 4 here. But in this first row, 4 is already present. So we will write 3 over here. Now let's look at the circle with the question mark. If we look at our first row, 4, 1 and 3 are already present. 2 is missing. So 2 will come in this circle. So option B is the correct option here. Question number 19. Lisa has 4 dogs. Each of the dogs weighs an integer number of kg. No two of them weigh the same. Their total weight is 60 kilograms. The second heaviest dog weighs 28 kg. How heavy is the third heaviest dog? So the total is equal to 60 kg and the second heaviest dog weighs 28 kilograms. Here, if the weight of the second is 28, so the weight of the first dog will be greater than 28. Let's try 30 kg. If the weight of the first dog is 30 kg, second dog is 28. In that case, the weight of the third and fourth dog can be 1 kg. Then total will be equal to 60. But here 1 is not possible because they told us that no two of them weigh the same. So we will reduce the number from here. Let's try 29. It is still greater than 28. So in that case, the weight of the third dog will be 2 and fourth dog will be 1 kg. So total is equal to 60 in that case. So that is the perfect equation. So we can say that the weight of the third dog is 2 kilograms. Question number 20. Jessie writes the 7 numbers 3, 4, 5, 6, 7, 8 and 9 in the circles in the picture so that the sums of the 3 numbers on each line are equal. What is the largest possible sum of the 3 numbers on the line that Jessie can get? So if we write 3 in the center and 4 and 9 in the upper circles, the total is equal to 16. So 3 is in the center. If we try 5 and 8 on the left side and 7 and 6 on the right side, the sum of all three numbers is 16. Now we can try 6 in the middle. In that case, if we write 9 and 3 in the upper circles, the total is equal to 18. So to make 18, we can write 4 and 8 on the right side and 5 and 7 on the left side. So 6 plus 5 plus 7 is equal to 18. 6 plus 4 plus 8 is equal to 18. And 9 plus 3 plus 6 is also equal to 18. Now we can try another combination in which 9 will be written in the center and 8 and 3 will be written in the upper circles. The total is equal to 20. So 9 plus 6 plus 5 is also equal to 20. 9 plus 7 plus 4 is also equal to 20. So here we have tried three combinations. So 20 is biggest of all. So option E is the correct option here. Question number 21. Some glasses are stacked on top of each other. A stack of 8 glasses is 42 centimeter high and a stack of 2 glasses is 18 centimeter high. How high is a stack of 6 glasses? So the length of the one glass is unknown. So let's suppose the length of the glass that is at the bottom is X and the length of the upper part of the glass is Y. So it is given in the question that a stack of 8 glasses is 42 centimeter high. So we will make our equation like this. X plus 7y is equal to 42. X because the length of the glass at the bottom is X and there are 7 glasses in it. So we will write 7 and only the upper part of the glass is shown. So that's why we have written 7y, which is equal to 42 centimeter. Then we have a stack of 2 glasses is 18 centimeter high. So our second equation will be X plus 1y is equal to 18 centimeter. So here we can see a glass at the bottom. X is representing its length and there is only one glass in it. So that's why we have written 1y. Now we will cancel the equations. We will subtract them. X minus X is 0. 7y minus 1y is equal to 6y and 42 minus 18 is equal to 24. We will move the 6 on the other side of the equal. So 24 will be divided by 6. That is equal to 4. Now we may say that the length of the upper part of the glass is 4 centimeter. Now our next task is to find out the length of the glass at the bottom. So we will put our value of y in equation 1 to find out the value of x. That is x plus 4 is equal to 18. Now we will move 4 on the other side of the equal. So 18 minus 4 is equal to 14. So in other words, we may say that the length of the one glass is 14 centimeter. Now we have to calculate the length of the stack of 6 glasses. So we will make another equation. That is x plus 5y. X is the first glass at the bottom and 5 glasses are in it. So total is 6. So we will put the values of x and y in the equation. So 5 fours are 20 and 20 plus 14 is 34. So option D is the correct option here. Question number 22. In the picture below, each animal represents a positive integer and different animals represent different integers. The sum of the two integers is in each column is written below that column. What is the largest possible sum of the 4 integers in the first row? So here we will start from the smallest number, that is 3. We know 1 plus 2 is equal to 3. As there is no 0, all the integers are positive. So 2 plus 1 or 1 plus 2 is equal to 3. We will write 2 above because we need the largest possible sum of the 4 integers in the first row. So that's why I have written 2 above. Then we have 7. We know 3 plus 4 is equal to 7. So we can write 4 above and 3 down. 5 plus 6 makes 11. So we will write 6 above and 5 down. And at last 8 plus 7 makes 15. So now we can add 8, 6, 2 and 4. The total is equal to 20. So option C is the correct option. The largest possible sum of the 4 integers in the first row is 20. Question number 3. To unlock this lock, you get the following 4 hints. What is the correct code for the lock? So if we look at the first hint, one of these digits is correct and in the right place. So the numbers are 6, 8 and 2. The second hint is one of these digits is correct but in the wrong place. So we can see that 6 is at the same place. So if 6 is correct, then it cannot be at the same place. So it means the wrong information is given about 6. So we are going to skip 6 from the list of numbers. Now, third hint is 2 of these digits are correct but in the wrong place. So 2 and 0 both are correct but their places are wrong. The fourth hint is all of these digits are incorrect. The numbers are 7, 3 and 8. If 8 is incorrect, so we can cut it from the first lock as well. Now we are left with 2. So it means 2 is the correct number which is at right place. Here we can look at our third lock now. If 2 is correct, it should be at the end. So now 0 is also correct but its place is wrong, so 0 will be moved at the first place. Now 0 is in the start and 2 is at the end. If we look at all our options, we got our answer already, that is option D, 042. But we can look at our second lock. It is given that one of these digits is correct but in the wrong place. So we have 1 and 4. If we look at all our options, there is no 1 given in any option. So it means 1 is not our number. 4 is the correct number but at the wrong place. So we will move 4 in the middle at the place of 1. So the number will be 042. So option D is the correct option here. 4. Anna has the shape shown on the right. Which of the following shape is the same as Anna? So here option C is the correct option, because when this bar will stand vertically in this position, the middle bar will be like this in horizontal position, and the bar which is attached with the middle bar, that will come under it, it will be down. So option C is the correct representation of the Anna's shape. Question number 25. Warner chooses 4 of the numbers 2, 3, 4, 5 and 6 and writes 1 in each box so that the calculation is correct. How many of the 5 numbers could Warner write in the shaded box? So here, if we try 2 and 6, if we add 2 and 6, the total is equal to 8, and after subtracting 3 out of it, the answer will be 5, which is our first number. If we subtract 5 out of 8, the answer will be 3, which is our second number. Now we can add 4 and 5. So the total will be 9. After subtracting 3 out of it, we will get 6. So that is our third number. We can subtract 6 out of 9 as well, but in that case answer will be 3, which is already written. So we will try another combination, that is, if we add 2 and 5 and subtract 3 out of it, the answer will be 4, which is our fourth number. If we subtract 4 out of 7, the answer will be 3, that is already done. So the last combination is that we can add 3 and 5, the total will be 8, and after subtracting 6 out of it, the answer will be 2, which is our fifth number. If we subtract 2 out of 8, the answer will be 6, and 6 is already done over here. So that's why we can say that we have 5 numbers which can be written in the shaded box. And question number 26, the numbers 3, 4, 5, 6 and 7 are to be placed in the 5 circles below so that the number inside each triangle is the product of the 3 numbers on its vertices. What is the sum of the 3 numbers on the vertices of the colored triangle? So here we can look at all the numbers. All these numbers are divisible by 7. The number 105 and 210 are divisible by 5. 105 and 84 are divisible by 3. Now 210 and 168 is divisible by 6. and 168 and 84 are divisible by 4. Now let's find the total of the numbers which are at the vertices of the triangle. 7 plus 4 plus 6 is equal to 17. So option D is the correct option. The sum of the three numbers on the vertices is 17. Question number 27. Which of the following nets cannot be folded into the solid? So here option B is the suitable option. We cannot make the solid from this net. Question number 28. The four villages A, B, C, and D lie along a road in that order. The distance between neighboring villages is 10 kilometers. There are 10 students who live in a village A, 20 students who live in village B, 30 students who live in village C, and 40 students who live in village D. The villagers want to build a school so that the total distance traveled by the students when going to school is as small as possible. Where do they build the school? We know that 10 students are in village A, 20 are in B, 30 in C, and 40 students are in village D. And the distance between each village is 10 kilometers. So if the school is built in village D, then 10 students of village A will have to travel 30 kilometers. And the 20 students of village B will have to travel 20 kilometers. And the 30 students of village C will have to travel 10 kilometers. So 1000 will be the total distance that the students of A, B, and C will have to travel. So let's say if the school is built in village C, then 10 students of village A will have to travel 20 kilometers, 20 students of village B will have to travel 10 kilometers, and 40 students of village D will have to travel 10 kilometers. So for C, the total distance will be 800 kilometers. If the school is built in village B, then 10 students will travel 10 kilometers, 30 students will travel 10 kilometers, 40 students will have to travel 20 kilometers. So if we find the total, that is 1200 kilometers. If the school is built in village A, then 20 students of village B will travel 10 kilometers, 30 students of village C will travel 20 kilometers, and 40 students of village D will travel 30 kilometers. So the total is equal to 2000. And if we discuss the option that in the middle of between village B and C, so we can see the total distance of B is 1200 and village C is 800. The middle is 1000. So option D is the correct one. The school will be built in village C because here the distance is least. Question number 29. The three pictures show a structure made from cubes as seen from the top, from the front, and from the right. What is the maximum number of cubes that could have been used to build the structure? So we can see that in front there is 1, 3, 3, and 1 cubes. On the right side there is 1, 2, 3, and 3 cubes in each column. So now we are going to write the number of cubes in the front side over here in front of top view. So we will write 1, then 3, 3, and 1 here. Now we are going to write the number of cubes of the right view at the right side of the top view. So we will write 3, 3, 2, and 1. Now we are going to apply a trick over here. If we talk about this cube, 2 is written at the right side of it and 1 is written at the front of it. So we are going to write the smaller number out of these two. So 1 is smaller, we will write 1 over here. Here at the right side it's 3 and in front of it it's 3. So we will write 3 over here. Similarly 3, 3. So we will write 3 again. Both sides have 3. So we will write 3 in both cubes. In this cube, at the right side it's 3 and in front of it it's 1. So we will write 1 over here. Here we will write 2 because it's 2 at the right side and 3 at the front side. Then 2 again, and now we have 3 and 1, so 1 will be written. After that, we are going to add the sum of the numbers written inside the cubes. So 3 plus 3 plus 3 plus 3, 12, and 13, 14, 15, 16, 17, 18, and 19. So option B is the correct option. There will be 19 cubes. Question number 30. 30 people are sitting round a circular table. Some of them are wearing a hat. These who do wear a hat always tell the truth, while those who do not wear a hat can either lie or tell the truth. Each person says, at least one of my two neighbors is not wearing a hat. What is the largest number of people who could be wearing hat? Uh, so now we have to make different combinations. It is given in the question that there are 30 people in total, and at least one of my two neighbors is not wearing a hat. So let's suppose that first person is not wearing a hat and the next one is wearing it. After that, the next one is not wearing a hat and the next one is wearing it. If we continue the pattern, so out of 30, it will be a 50-50 chance. So 15 people are not wearing a hat and the 15 are wearing a hat. Now let's make another combination here. First person is not wearing a hat, but the next two persons are wearing a hat. Then similarly, the next person is not wearing it and next two persons are wearing it. So on. So here, out of 30, 10 persons are not wearing a hat and 20 will be wearing the hat. Now, the third way is that first two persons are not wearing a hat and the third person is wearing it. Then after that, next two persons are not wearing it and the next one is wearing it, and so on. So here, in this case, out of 30, 20 persons are not wearing the hat and 10 persons are wearing it. So if we look at all the numbers, 20 is the largest number of people who could be wearing a hat. So option D is the correct option here.